everyone. In this video, we are going to talk about load balancers and some of the key questions that you are expected to discuss in your system designs interview round for load balancing. Now, load balancing is a very common question that is asked to developers, to QA engineers, to network engineers, and of course to DevOps engineers. So you are expected to have a good understanding of load balancer, not only the surface level, but a little bit deeper than that. Having said that, this is not going to be a beginner's video to load balancer. So I'm expecting that you have some kind of a knowledge with respect to load balancer. What we are trying to achieve in this video is to answer questions like what kind of different load balancers you have used or you should use in your project. If you have implemented load balancing on Kubernetes or containers, then what are the options that are available? Which one did you prefer? If you use load balancing in AWS, GCP, then what kind of load balancing problems did you encounter and how did you mitigate them? So those are the kind of questions that we are going to answer in this video. Not a lot of theory content, so we will directly jump into the questions part. Let's get started. As always, we start with a pictorial representation of the topic. Say there is a user and the user wants to access a URL, which is like booking.com. Can be any URL, doesn't really matter. And the URL routes from his mobile to the internet and then eventually reach the endpoint or the desired server, which is actually serving the requests. Now, if you try to understand this block, this is where the load balancer, or this is on the left hand side of the picture, is where the system components or the server components of the booking.com reside. This is like a very basic diagram, but if you dig inside, the booking.com server is not going to serve you directly. Right? There will be multiple layers of network components, and you will very quickly realize that load balancer is either the first or the second layer of that stash. So there will not be any booking server directly responding back to this particular user. What there will be is a load balancer or multiple load balancers which are actually responding back and which are actually listening on a particular URL, right? In this case, the URL is booking.com. Now, if you go one step deeper, you will realize that load balancer within itself does not have any application logic for booking.com. So it doesn't know how to authenticate a user, it doesn't know how to process any request from this user. All it knows is, as the name suggests, is to balance the load. So if there are 100 requests that are coming to this load balancer, it will bifurcate those requests or distribute those requests to its endpoint, or sometimes also called target group servers. Say in this example, there are 3 servers, S1, S2 and S3. All of them will be listening to this load balancer, and this load balancer will perform the act of balancing the load or evenly distributing or distributing based on the conditions that we provided within these servers. So all the application logic will reside here in these servers, and the only role of the load balancer is to fetch the request and then process it forward to these servers. If we go one more step deep, then we will realize that the way in which the load will be distributed is not ad hoc or is not, based on guesses. There are actually configurations and there are rules that these load balancers are required to adhere to, and based on those configurations or based on the rules, the load balancer will decide which server to facilitate or which server to provide to the user. And these rules are very specific to what kind of load balancer you are using. There are multiple vendors which are available in the market which provide load balancing as a software solution. So gone are the days when this was a component for network engineers. Now everybody can install a load balancer. In fact, we are going to install load balancer, and we are going to in fact install multiple load balancers and see how these rules are actually configured in the runtime or in the hands-on. But just remember that based on the selection criteria, on this side there are the rules. So you can decide the wait time, you can decide the geolocation. Say for example, the user is in India and you have some servers which are in India and some servers which are in the Europe. So of course you want the servers which are in India to facilitate the user if they are available or if they do not have the load. So you can decide, you can create rules based on multiple policies, and geolocation is a very commonly used policy. Sticky session is if your load balancer is capable of having some kind of session management, or it is capable of having caching, then you can cache the static content for that user, and this will increase your response time. Then there are other rules like round robin, or checking who is free and then deciding who should serve the next request. There are even more rules, a larger number of content than this, but for our discussion this is more than enough. If you are able to understand all of these rules, you're good with this rules part at least. Then on the other side of the configurations, or on the other side of the configuration file, you actually have the IPs, or the location of the servers. And this can be physical servers, this can be containers, this can be distributed servers. So this actually depends on what kind of architecture we are setting up, but for our reference we can just picture them as VMs. So this, let it be server 1 is hosted in VM1, this guy is in VM2, this guy is in VM3. Largely this is what you will have. You will have configurations, you will have rules. These are what your load balancer will check before processing and providing this user with the desired output, and the desired output logic is going to be present within server 1, server 2 and server 3, and how we choose them is going to be specified by our configurations and rules. So that brings us to the first question which we are going to discuss, that is, what are the different type of load balancers, and how do you actually implement them? So broadly you can say that there are two types of load balancer. One that work on the layer 4 of TCP/IP protocol, which is this guy, which are also called layer 4 based load balancing, and the other ones are also called application load balancers, and they work on layer 7 on the HTTP or HTTPS protocols, right? We will be creating both of these load balancers to give you a better understanding. This is very important discussion, and from here the basis of the interview will go on. So we will have to spend some time in understanding these two different, or these two basic type of load balancers. If you go with cloud vendors, then you might see, you know, people calling classic load balancers or ELBs. Those are just fancy terms. Broadly there are only two load balancer types, which are these two guys, and then one works at layer 4 and another works at layer 7. We'll see the advantages and where do they actually fit in. So going back in our pictorial representation, this is actually a layer 4 load balancer, because here we termed that these servers can reside in different VMs. So all the work that the load balancer has to do is to see which of the server is available, and then just forward the request to that server. So all this guy has to do is just see which server is available based on the rules, and then which IP is where the traffic has to be forwarded. So this is another very important part here, because load balancer does not have to break the traffic. It can be one static traffic. There is no header that it has to break, and no application layer information that it has to fetch. As a result, the layer 4 load balancers are very faster, primarily because it is on the lower stack of the TCP/IP. It is faster, doesn't have to do too much of thinking, just has to see which of the server is available, what are the rules, and then just forward the traffic to that particular server. All right, so let's see how this looks, how you can actually create a load balancer at layer 4. By the end of this video, I'll be giving you a description of where to get this project. I have not created this one. I've used it from internet, a very good example which you can also install within maybe 2 to 3 minutes. That's all. You don't have to write any Python code, no Docker file, no compose file. It's already available. I'll give you the link within the video itself and also in the description. So I have two folders. One is called load balancer layer 4, load balancer layer 7. So let's go into So let's go into the layer 4 one first. Right, so this is the content that it possesses. Let me just quickly walk you through what it is doing. So I have two applications. One is called app1, another one is called app2. You can consider these two applications to be of same data. So both of them, if I say that both of them are serving the backend of booking.com, just picture that both of them have the same code. There is no code difference between app1 and app2. This is just for the naming conventions I have given, like app1, app2. These are both apps, both have the same data. This one is going into a different server, into a different VM, or into a different container, and this one is also going into a separate container or separate VM or a separate server. Then I am using Nginx as a layer 4 load balancer for myself, and what this guy is doing is, if I open the Nginx config file, now this is where you define the rules and you define the configurations. We have configurations as the IPs, and you call it upstreams. This may vary from server to server, but just understand that you provide the IPs and you provide the port. So I'm saying that both of them are going to reside in two different containers in my laptop. One will be accessible on 5000, another will be accessible on 5002, and I'm giving equal weight. I can give say for example, I want the server or the app 1 to get most of the load, then I can give this as 7. If I want this one to go less load, or if I know that this server is going to be smaller in capacity, then I can give it as 3. Right, so let's keep it 5. Oops. All right, so what the end user is going to hit is load balancer. This is let's say this is my booking.com. So of course that domain I don't have, so I'm using a load balancer.com. But in our example here, this is the endpoint that the customer is supposed to hit, and when it hits the load balancer endpoint, then it will go towards the internet or towards the network, and then it will hit the load balancer, which is layer 4, and all of these servers, which is in our case app1, app2, and we don't have app3, so let's keep it to app1 and app2. So app1 and app2 are serving the application code of load balancer, and load balancer, what I have here is Nginx, and we have defined the rules. We are going with weighted rules, right? This is our configuration section. All right, so let's see how it runs. So project is a Docker Compose project, so you just have 2 to 3 commands to remember. After you clone this project, you just have to do a Docker Compose. So what this command will do is create 3 containers. 2 of them will have the same image, that is app1 and app2. Both of them are Python based project, has the same image, and it will create an Nginx container, which is this guy here. So we have 3 containers are going to be running. Let's cross check if anything is running here. All right, so it started 2 projects or 2 containers of a Python 3, I think, yes, and then one of Nginx. Of course, there is a there's a disclaimer: don't use this in production. This is just for the demo purpose, okay? And then Nginx is what we are tailing in the log section. All right, now let's go to the browser. So in the browser, what we have to do is localhost port 8080. Now, how do you know this port 8080 is what you have to hit? That information is given in the compose file. So within the compose file, I have defined 3 services. If you're not comfortable with Docker, or if you're not comfortable with Compose, Docker Compose, that's fine. Just understand that you have defined 3 services. App1 and App2 are both serving for the application that we are talking about, let's say booking.com. And then within the container, 5000 is the port that it is facilitating the application output with, and the output is very similar, very simple output. It's like you are just saying that, hey, I am a static IP, app1 says that my static IP address is 11111, and likewise the app2 will say that my static IP is 2222, right? Again, you don't need to understand Flask, and you don't need to understand how Python works. You don't even need to install Python in your laptop to run this project. It's a very simple one, and like I said, I'll give the link in this video as well as in the description. So I hit the URL and I get your request is being served by IP address 111. That means app1. So let's confirm that it is being served by app1. That's what we see in the logs here, right? 200 OK, and this is being served by app1. What we can also do is we can open the network tab of our browser, and let's refresh this again. Okay, now it is being served by 222. Remember that our rule is a weighted rule of 5, so that means every time the request come, whichever served the request, the earlier request will not serve the next request because we have equally weighted them. But here nothing changes in the URL. If I, instead of giving 8000, if I give 5001, this is again going to app1 server, but never in your browser URL you will see this port being displayed, right? So this is always going to be like this. Okay, so the reason I'm talking about this is because load balancers also act as a very important component of providing security within your entire system. They act as reverse proxy servers. What are reverse proxy servers? First of all, understand what are proxy servers. Whenever a customer is sending a request to the internet, say this guy is sending the request to the internet, and then from the internet there will be network address translators and all of the different networking components. If you're interested in those kind of questions, I have a video for that. Okay, go check that out. I have done a detailed explanation of networking questions, but for this video let's keep it short. So this guy goes to the internet. Whenever the request is coming from the customer, right, or from this guy here, his IP will be attached to the headers of his request. Now if you want to hide the IP, or if you want to be anonymous on the internet, what you can do is you can use something called a VPN. And what this VPN actually does, it creates a proxy, or it acts as a customer or as an endpoint to the rest of the world. So your requests will go to the VPN, and VPN will do the network address translation, or it will change the IP address from which the request is coming and then provide it to the internet. So the internet or the server which is serving you back will never know who is the actual customer. And this is called proxy, right? When the server or the endpoint which is serving back to the customer, that is in our case this guy, gives the request back to the internet, and then that information is given back to the customer, it also attaches its IP address within the header. So you will come to know who is the endpoint that is serving you. If you want to hide that, you can use something called reverse proxy, or load balancers are kind of a reverse proxy, because nowhere within your network package you will have the information about these servers, server 1, server 2, server 3. You will always have information of this guy, which is your load balancer, and this can be a static URL. In our case it was showing localhost because I'm hosting this setup in my local laptop, but in real world you can say abc.com or anything, and that is the IP, or that is the information that would be embedded. So this is a very important interview topic, where you need to explain how load balancer provide enhanced security, and how it provides as security as a reverse proxy and also as a gateway. We have not spoken about gateway. We'll talk about that in layer 7. So let's stick with the reverse proxy for now. So again, load balancer is going to do network address translation. That is, the IP of S1, S2 and S3 will always be hidden from the end user, and end user will always end user will never know what is the IP of these guys here. Okay, going back to the logs, you can see that Nginx is always being hit, that is the load balancer is always being hit, and then the app1, if app1 is serving you, app1 will get the request. If app2 is serving you, then app2 will get the request, but always it's going to be Nginx which is going to be hit by the customer. Okay, great. So let's stop this setup now. Okay, so this is how the layer 4 or this guy works, right? And this is how the load balancers which work on the layer 4 function. And now let's see how the load balancers which are at the layer 7, how do they function. Now, sticking to the same example, again the user is hitting booking.com and it is going to the internet, and then from the internet it goes to the load balancer. But this time the load balancer is not sending the request directly to the servers. This time it is trying to understand which is the service that the user actually wants. Does it wants to go, or does the user want to go to the home page? Then I should see which is the one that is serving me the request at the home page. It says, oh, this is the service that is responsible for serving at home page. And then within this service there can be another layer or another mesh of servers which are all serving for homepage. So this guy also serves for homepage, 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 but this is the identifier for the load balancer. Now the load balancer is trying to act smart. It is trying to understand what is the request instead of directly feeding it to the servers and then letting the servers do the work. Now it is trying to understand which is the service or which is the microservice, if I may say, that is responsible for serving this kind of request. And this is the main difference where L7 load balancers differ from the L4 load balancer, or this is the way in which they actually differ. When they try to understand what is the request that is coming in my way, and the architecture is a microservice oriented architecture where you have different endpoints. Say for example the user wants to visit booking.com/info. Then when it reaches to the load balancer will try to see, all right, which is the service that is giving me answers to the info pages, and then it will only provide the load to the info. It will not provide the load to the home page, even if the home page is ideal or it has the capacity to deliver faster results than the info, because this guy is not serving the desired content back to me. It will wait till the info is available and then it will provide the information to the info microservice. This can be a different microservice altogether, or this can be a same microservice which has multiple endpoints. That entirely depends how the application is created, but ideally what you will have is multiple services respond, or multiple services have different endpoints. So altogether if you combine them, they become a booking.com website, but internally the info might be a different microservice, checkout or payment might be a different microservice, and home pages or home content might be a different microservice. So now the load balancer has more work to do, right? It has to understand the request, it has to understand the servers or the services. So naturally there will be a different kind of a configuration which is required for this kind of setup. So this is how the configurations page will now look like. You will see that this load balancer is now serving as a gateway to other microservices. So it's a gateway for home microservice, it's a gateway for info microservice, or it's a gateway for checkout, which when we combine all of them, these are nothing but the functionalities of booking.com. So in this case, you will have the IP addresses of these services and not the endpoint servers, right? Now, a service can have multiple servers. All right, so there is a kind of an inheritance, or there is kind of a recursion happening here. So this becomes easy to understand if you have some hands-on with Kubernetes, and if you understand some controller object like an ingress controller in Kubernetes, where this kind of infrastructure is very common. This time our configuration file looks something like this. So you have component, again this is an Nginx specific tag that you are giving. So basically what you're saying is, whenever there is a request that is coming to booking.com and that has /home, then you should return it to this particular container. And if you recall from previous example, we have already defined a service which is app1, and this guy should fetch you the request back. And likewise, if you want info, then there is a different server, or there is a different container in our case, which should serve you the request back. So this is going to be app2. It is not necessary that all of them are hosted in the same server. This can be like server 1 or VM1. This can be in VM2. This is just for the sake of simplicity and for the sake of ease. This is just for the sake of this demo. I'm keeping everything in the same server, but you can redirect them to different microservice services endpoints. All right, let's get this guy running. Now, I have again opened up the browser console. You can see that this is still having the cache from the older results. Let's refresh this, and I'm hitting localhost port 8080, and it says not found. Now the reason is because I have not specified any default home location. So if you see here, I have just said /home and /info. There is nothing like this, which means that if there is nothing specified in the URI, then you go here. So I am only serving at 2 URIs. So let's give it /home. Now, as soon as I hit /home, you are seeing that it is called in here in the network tab. It is calling /home, and it is also calling the home API, and you are getting 302 status code, that is an HTTP status code or HTML status code, which is saying that you have been redirected. I have purposefully kept it. You can also hide it. But what I'm trying to show you is that now, in the earlier example, you were seeing that localhost was always serving you the request, and you were not getting information about the redirection path. Here, because this guy is acting as a gateway, what is happening is that your request is being served by a specific container or by a specific microservice. Now, if we change this guy to say info, so instead of giving home, let's give info. You see now this is being served by the info API. So when I'm saying home, this is going to app1, which is in my case service 1. When I'm saying info, it is going to app2, which again is a service 2. So in this case, the load balancer is actually acting as a gateway. The configurations are different, and then when you are acting at layer 7, you can also have something called TLS certificate validation check, that is to have the authentication checks, because now you are actually bifurcating, or you are breaking the package. You are trying to understand what is coming into the URL. So this is again one important concept, or one important interview topic that you should discuss, that where does the SSL termination or TLS termination happen, and you can read about this more, a very common interview question that is asked. One key point here to remember is that because your load balancer is now trying to understand what is there in the URL, this is significantly slower than layer 4, because there it was not checking for anything. It was getting the information, checking the rules, seeing who is available or what kind of rule it has, and then forwarding it. Now it has to understand which is the endpoint or which is the microservice, and then it tries to provide that information. So this is substantially slower. In the actual systems design, when you will be designing something for a new infrastructure, you are very likely to have both versions of load balancers, but it is very important for you to understand and to explain the different types. And like I said, broadly you can categorize them in 2 types, and we have seen both of those types and how to explain that in an interview. Another very common question which is asked in in respect to this topic is how are you, or have you set up load balancing, or how is your load balancing being managed at the Kubernetes layer. This is the ideal services networking page that you should go and check out. Remember to explain the services, cluster IP, node ports, and ingress controllers when you are discussing this topic. It actually requires a entire video for discussing them in detail, but maybe we can do that in some other video. Make sure that you are aware of how Kubernetes takes care of load balancing. So basically, service networking is the answer, and then there are different flavors to service networking, which are explained in this documentation. In terms of AWS, you would be asked what kind of load balancers you are aware of and how to implement them. Again, there are broadly only these two load balancer categories which we spoke about: application and network layer. Network layer 4, application layer 7. Then there was something called a classic load balancer, which could act like a network when it wanted and application when it wanted, but we don't generally use this kind of load balancer now. People don't talk much about the classic load balancer because this was retired last year, I think somewhere around August. So again, you have to remember the same example, and then logically the differentiation is exactly the same. How it behaves in containers, it behaves the exact same way in the cloud vendor services, but here you get certain additional features, and you might be asked about WAFs and shields. Remember to check on those two topics. Those are kind of a protection layer that you get when you choose a load balancer service vendor. So these guys provide you an added feature or added functionality, so as to say, in terms of security. These are both WAF as well as shield are both security components which work on top of your load balancers, and they also have very good mechanism of bifurcating the requests. So basically you can define a regex, and if any information is cached between that regex, then that request will not even come to your services, or not even come to your service. It will be directly rejected by the load balancer WAF or shield itself. But this functionality you cannot get out of the box when you are setting up a load balancer by yourself in your laptop or in your server. So make sure that you are catching on those topics. A question can be something like, what is the added advantage, or why should you choose a load balancer service from a cloud vendor and not create one from yourself? Again, TLS, and also check the Cypher or cross-site scripting, the advantages and the features that they provide as an added security to your entire system. In terms of Google Cloud, again, conceptually the topics are exactly the same, but they have explained it a lot better, I think, in terms of proxies and in terms of external and internal load balancing. So there are certain load balancers which can be accessed only within the network, so those are called internal load balancers, and then there are certain load balancers which can be accessed from outside of the internet as well. Just like in our case, the load balancer was an external load balancer which could be accessed from outside of the internet. But there are cases when you have a load balancer within your network and you only want it to be accessed within the network. That is called internal facing. Common example of that is load balancers which are used on top of databases. Don't go into that direction, because load balancing becomes a little bit complicated when you talk about databases, but you should know that how it works. Maybe we'll create another video for having a dedicated discussion for load balancing on databases, but just try to remember that there are cases when you want the load balancer to be only internal facing and not internet facing, and that is very nicely explained in the Google Cloud documents, is what I feel. For the Azure load balancers, again, the same thing applies. They explain how standard load balancers work, how gateways are configured, and how basic load balancer works. So theory part is pretty much the same. If you're going for any interview round which is specific to Azure, then I recommend you go and check this documentation. Otherwise, you are good with the documentation of Google and AWS. Like I said in the beginning of this video, I did not create this project. This project is readily available. Here is the link of the same. All you have to do is make one change, because this was done a couple of years back. So they were using an older version of Flask that is here in this requirement document. So when you do a git clone of this project, take the latest version of Flask which is available. I think I am using 2 point something. Let me check what I'm using. Yeah, I'm using 2.1.0. so if you use the older version of Flask, this is not going to run. And Flask is nothing but a fancy name given to a Python project which enables you to run applications. Some of the load balancers like Nginx, they can act on both of these layers. It actually depends on how you want to implement them. And you should know which one is faster, which one is working on which protocol. I have highlighted the protocols here. What are the advantages of using layer 7? What are the advantages of using layer 4? What are the disadvantages of using them? Basically, I don't see any disadvantage, but yeah, you should know which one to choose over the other one based on your use case. Then you also need to discuss cloud vendors, and you also need to discuss the security component of your application. And one key concept which you should also discuss in your interview is how load balancers facilitate auto scaling. I have created an entire video on auto scaling and how auto scaling is being used in applications. So load balancers are key component for auto scaling, be it whenever you are talking about horizontal auto scaling, then load balancers are I won't be wrong to say the father of auto scaling. If there is no load balancer, they would have never been an auto scaling. So make sure that you check that video as well. So talk about load balancers with respect to how it facilitates or how it helps the other system design components to function. After this, the follow-up questions will be on failovers and on upgrades. So you need to know how a load balancer works in terms of failovers. So basically, the configuration remains not that much different from what we already saw. You define rules, and say for example your rule is like wait time, and you say that if I don't get a request back within say 5 seconds, I'm not getting anything back as a request. What you do is instead of keep on waiting for the request, you go and try the other servers. So the request will first go to S1, and if I'm not getting information back within 5 seconds, what load balancer will do is that it will declare this guy as down. Now again, it depends on the specific kind of implementation that we are using for the load balancers. You can permanently mark this as down, or you can only mark this down for that specific interval or that specific call. But what we achieve with load balancer is a mechanism where we always have a high availability for our website. So a facility of failover, and you also get a facility of HA with load balancer. And you need to just basically define what is your failover criteria. Most of the times it will be on the time of the request or the response that you're getting back. If that time threshold is meted, and then you define, say for example, you will get a use case where 5 seconds is the minimum. In reality, it will be even lower than 5 seconds, but let's take 5 seconds is the response time you're expecting. And then there is a failover time, or there is a fail count, and you say fail count is equal to, say for example, 100. So if if the server 1 fails for the first time, it will become so this guy will be incremented, or you will keep on adding a counter. So unless this guy is, say for example, 99 is not equal to 100, so the server will still consider this as up. But as soon as this becomes 100 and 100 is equal to 100, then automatically the server will be termed as down server. Then another important question or important topic for discussion is upgrades. In present day scenario where everything is microservice based and most of the things are service oriented, you cannot afford to have downtime. So your upgrade strategies are most of the time either rolling upgrades or either they are blue green upgrades. In either of the cases, you need to have a load balancer to facilitate a zero downtime upgrade. So what this means is, if I want to upgrade the software version of booking.com and say all of the softwares are running on version is equal to 1.2 and we want to go into 2.0, we don't want the service to be affected all at once. So what we'll do is we'll only update one server or one infrastructure component here at a time. So this one goes down, and then you upgrade it and provide the new version of S1, which is of V2. Then it comes back into the environment. Until that time, these two servers are still serving you the request on 1.2 version. Again, all of this is possible because you have load balancer providing you the feature where you can attach new servers to the existing services or to the existing endpoints. So in my opinion, these are the questions that would be discussed in any system designs interview round, and specifically targeting load balancers. So whenever you are asked how do you debug a problem which is related to the load balancer, most often you should talk about the target groups and whether any service or any server within the target group is down, what are the rules, and if you have configured the rules properly, if there is a threshold counter that has been met, and now that S1 is back up but the fail count is already reached 200, so this will still be termed as down. So these kind of questions would be expected to be discussed whenever you are giving an interview round for load balancer. So in my opinion, you are good if you answer all of these questions. That is at least sufficient for me if I am taking that interview. And yeah, I think those are the most commonly discussed topics, and I hope you learned something new today. You found it informative, and if you did, then do share it with your network, and I'll see you in the next one.